Hello students, in this video we are going to learn about estimation, which is chapter number 7, estimation. So managers have to make estimates when they are working for organizations. You can just go through this initial introduction so that you understand the importance of proper estimation. There are two types of estimates: point estimates and interval estimate. Point estimate is a single number that is used to estimate an unknown population parameter. An interval estimate is a range of values used to estimate a population parameter. So when the manager takes a decision and gives one single value for it, for example, what will be the sales estimate for the next coming month, and if he says okay, it is going to be 10,000 strips of sales, then it is called as point estimate. But when he says it will be somewhere between 9,700 to 10,200, then what he is doing, he is giving an estimate which has a upper limit and which has a lower limit. So interval estimates interval estimates and confidence intervals. So whenever we give estimates, it has to be with a certain confidence level. So the manager has to then say that I am 90% confident about the interval I am giving, or I am 95% confident about this interval. What he means by that, 95% chance is that the sale for the coming month will be between these two limits, and only 5% chance. Why 5%? 95, 100 minus 95 is 5. We call this 5% as significance level. So significance level 5% means there is a 5% chance that the sales in the coming month will be out of these two limits. So it can be higher than the upper limit, or it can be lower than the lower limit. Right. Now how to go about solving the problems? See, we are still again going to use the same Z formula, but then there are variations and with little bit of different arrangement of the same formula. So let us first look at calculating interval estimates of the mean from large sample. So whenever you have a large sample, n is greater than or equal to 30, then you can be either estimating population mean given a sample information, or estimating sample mean given population information. So when we are estimating the population mean, our formula will be mu equal to x bar plus or minus z times sigma x bar. So it is actually the formula for z which we have learnt earlier. It is rearranged. Sigma x bar is nothing but sigma upon root n. And secondly, when you are trying to find out estimate about sample mean given the population information, then mu will come here, x bar will go here. So x bar will be equal to mu plus or minus z times sigma x bar, and again sigma x bar is sigma upon root n. In case the population standard deviation is not available, then we have to use best estimate for the population standard deviation, and in case the best estimate also is not available, or reliable best estimate is not available, then we have to take the sample mean as the best estimate. So we can take sample mean upon root n, but then we have to mention that clearly in the exam that because sigma is not available, we use sample mean as the best estimator, and we are going to calculate the standard error. Sigma x bar is our standard error. So let us take example. So the first example goes like this. For a population with known variance of 185, a sample of 64 individuals leads to 217 as a mean. Find standard error of the mean, and second part, estimate interval estimate for that should include population mean for 68.3% of time. So clearly here we are going to be using the equation where we are trying to estimate the interval for the population mean. So the first one, mu equal to x bar plus or minus z times sigma x bar. X bar is already given as 217. So how to solve this? First, they have given us the population variance. So square root of that will be our standard deviation. So population standard deviation will be 13.6. Sample size is 64n. So therefore standard error sigma x bar equal to sigma upon root n. Just try to do this. 64 square root is 8. So 13.6 divided by 8, it will be 1.7. Hence our standard error is 1.7. And sample mean is already they have given 217. So we substitute in the formula. So our interval for mu will be 217 plus or minus, means in one time we will use plus, in another time we will use minus. Z times 1.7, because 1.7 is our standard error. Now Z is supposed to be equivalent to or is for 68.3% of the confidence level. So that means what? This particular area between the two limits, upper limit and lower limit, should be 68.3%, right? Or probability of the population mean falling within these limits is 68.3%. You can put it in any way. But you know that our table, we have to use this table again, and you know that this table is for the half the area, that is between this 0 to this positive value of z. That means what? We are going to now look for z value for half of this, which is 34.15. So if I go to the table, where is my 34.15? You will see it is here, somewhere here. This is the closest one. So z equal to 1.00. So my z value equal to 1.00 is this area is 34.13. So hence my z is equal to 1. We substitute here. So 217 plus 1.7 and 217 minus 1.7 will be the two limits, upper limit and lower limit. So it is coming like this. 215.3 is my lower limit, 218.7 is my upper limit. So this is my answer, the upper and lower limit, where I am 68.3% confident that the population mean will be between these two. Now let us see a variation for this, where population mean is 100, a sample of 64 is drawn, whose standard deviation is found to be 10. Find the interval estimate for the sample mean between 95 and 95 and with 95% and 99% confidence levels. So clearly we are trying to establish interval estimation for sample mean, and hence we will be using sample mean equal to mu plus or minus z times sigma x bar. Sigma x bar is sigma upon root n. So if you substitute n equal to 64, so this is square root of 64 is 8. So sigma is given to be 10, standard deviation is 10. Because we don't have population standard deviation available, we use sample standard deviation in it as the best estimate for population standard deviation. So 10 divided by root of 64, 10 divided by 8 is 1.25. So our formula will be x bar plus 100 is the population mean plus or minus 1.25 times z. So now for 95% confidence level, we have to look for 47.5% and we get from the table 1.96. And when we use that, we get upper limit as 102.45, lower limit as 97.55. When we use 99% confidence level, then we have to look for 49.5 and you will get z equal to 2.58, and then we use that and you will get upper limit as 103.225 and lower limit as 96.775. Clearly you can see the 99% confidence level ka limits are wider than 95% ka limits, obviously, because now we are having to include 99% of the area under the curve. So these are the two variations here. If population mean is given, you are going to estimate sample mean. If sample mean is given, you are going to estimate population. So we will now look at, in my next video, we will look at t distribution, which is estimation from small samples. Thank you.